Hello and welcome. In this video, I'm going to design HDMI Video Pipeline. Finally, I will use Digilent Pynq-Z1 development board to implement this design. After successful implementation, I will feed video through input HDMI port and will get video from output HDMI port. In this design, the video will not be processed but get passed through the board. Here I have used Vivado 2019 version 2. In this design, I will not cover the steps for creating new project in Vivado. If this should be included in the video, then let me know in the comment. I will include this in the next video. And also, I will not cover the entire information of the board. More information can be found on Digilent website. Here I have already created the new project, and let's begin creating with a new block design. Let's give design name. Now we can start making block design in diagram workspace. But before that, we have to add Digilent IP repositories to this project because we need to have HDMI interface for the design. Here I have added Digilent Vivado IP libraries. The IP's repo can be found at GitHub and Digilent website. Let's start making block design by adding IPs to workspace. Let's add DVI to RGB and RGB to DVI IPs for HDMI in and output interface. These are the Digilent IPs which are available after adding Digilent IP repos. Let's add other IPs, for example, X4 to Video Out IP, Video In to X4 IP, and Video Timing Controller IP. Now we need clock source, for which we can drag and drop system clock to the workspace. This adds clocking wizard to the block design. These are the basic blocks for pipeline design. Let's add a constant IP block. Let's copy it down to 2. The constant IP block is used to provide constant 0 and 1 value in the design. Let's customize this constant IP block to set 0 value. And rename this block 0. In the similar way, let's customize another constant IP block to set the value 1 and rename it as 1. Let's customize clocking wizard IP to set output clock value. Under output clock tab, set output clock value to 200 MHz. This clock will be supplied to DVI to RGB IP as reference clock. Now we can start joining the IP blocks. Connect clock pin to reference clock of DVI to RGB IP. Let's connect all the other IP's clock pin to the pixel clock pin of DVI to RGB IP. We also need to customize Video Timing Controller IP. Let's open its customization window. We can uncheck X4 Lite interface as there is no host processor in the block design. Let's scroll down and under generation option, check auto generation mode. By checking this mode, the video timing controller IP will be able to detect and generate video timing dynamically. We can let a video format as it is when video timing controller is in auto generation mode. Let's connect RGB interface to Video IO-In interface of Video In to X4 stream IP. And connect this Video Out interface to Video In interface of this Video Out IP. And we need to connect this Video Timing Out interface to this Video Timing In interface of BTC IP. And finally, we need to connect this Video Timing Out interface to Video Timing In interface of this Video Out IP. These video timing interface connections are required for video timing detection and generation. This video out IP finally converts XC4 stream into RGB stream, which is needed to connect RGB interface of RGB to DVI IP. Let's regenerate the layout. In video timing controller IP, this clock generation enable pin is used to enable or disable video timing generation. This is connected to video timing generation clock enable pin of this video out IP. By this video out IP will enable or disable the video timing generation for the synchronization between video stream and its timing. Let's connect this 0 constant block to reset pin. This will not do resetting the clocking wizard IP. Up to here, we have completed the block-to-block connections. Now we have to define external ports. Let's make this external. This will become HDMI input port. And also make this interface external. Let's make this interface external. This will become HDMI output port. Let's make this constant block output pin as external port. This will become HDMI hot plug detect port. I'm going to rename this port as HDMI IN. This will help me for constraint mapping. I'm going to rename this port as HDMI OUT. And also renaming this port to HDMI IN DDC. Let's rename this external port as HDMI SPD. This will become HDMI hot plug detect pin. Let's validate the design. Since we have no issues on our block design, let's head for adding the constraint. Here we can either add or create a new constraint file, but here I'm going to create a new constraint file for the design. Here we need to write or add constraint for external ports of the block design. I'm going to copy and paste HDMI constraint for Pynq board from GitHub. Here we have to rename the constraint name as according to our block design external ports. But all the constraint name look like same as our block design ports, so we don't need to change them. But this looks like we need to rename this constraint according to this HDMI SPD port. Finally, we need to create SDL wrapper to begin Bitstream generation. Okay, now we can head for Bitstream generation. We let here Vivado to complete the Bitstream generation. Bitstream generation is successful. We can now head for running the design. This design does not use any host processor, so we can directly move to launch this design. Before programming the board, we need to make sure that the board is properly connected and powered. Now let's program the board. Here at the top left, we will be able to see video output, while at the bottom left, we can see Bitstream programming to the board. The Bitstream programming is successful. We are now seeing the video output. This design simply passes input video to output. So we are seeing exact copy of this PC screen onto the output monitor. Here I have included the demo of this design. In this way, the HDMI video pipe design implementation completes. Thank you for watching.